Okay. And then really quickly, where did it go? It's fine.
What are you looking for?
I was gonna go to your sound, but I think it's fine. That's just like the output. So
Yeah.
you're not playing any like videos or
No, no,
anything.
no.
Okay, cool. I think you're good to go. Just make sure you stay close to the. All right.
Whoa, what happened?
Oh no.
What?
I love technology so much. It's like the screen turned off. Well, that's tragic.
Can I unplug it and put it back in?
Yeah. This is how we're. Wait, or not, maybe not that one. Hold on. Yeah.
Oh.
There we go.
Okay, cool.
And it's still recording? Good.
Yes.
All right.
Ooh, let's go back. Cool.
Okay. Now you're good.
Yay. Okay. This is exciting. Hi everyone. I'm Isla, if you don't remember. This is my mom. And we're going to be teaching today's lecture. So it's exciting to see so many of you in person. This is really great. So I guess a couple announcements before we jump into it. Homework 1 is due this week. It's going to be due on Wednesday, right before class. So that's 3 p.m. And we have office hours all scheduled. Oops. We have office hours scheduled. We have rooms for all of them and everything. Emily's is today at 5. So if you want to get a jump start on that homework, you definitely can. Yeah, those are the announcements. And then we kind of have a fun icebreaker that James really wants to do.
Yes. Okay. So yeah, they're going to be teaching today's actual material, but I told you on Zoom that we were going to have fun icebreakers in person because icebreakers are absolutely ass on Zoom. So we're not going to do that. We're going to do it here. So I really love music, and it's kind of like a staple of every class that I help teach or teach. I make a playlist for it so that I can like look back and think, that's like what my students were like. So today's icebreaker with the people around you, we're going to kind of share music tastes, and that's how you're going to break the ice. So you don't need to tell people where you're from and your favorite lollipop flavor or something stupid like that. Music is way better. So I'll get out a piece of paper if you have one or whatever you want to write with or something. But it needs to be given to us. So preferably a piece of paper with a pen or a pencil. If you need something, we can come back and come help you. But get a piece of paper out, write a couple songs that, maybe your favorite one, maybe what you're feeling right now, reminds you of break. Write a couple songs on a piece of paper. No more than 2, please. Just no more than 2. And share it with the people around you at your table. No judgment here. You could put Dora the Explorer theme song if you want. I know. It was funny though, right? I think it is actually. I think we'll play it this semester. We will do it this semester. Also, for the people on Zoom, where is the Zoom? Are you sharing your screen?
I think so.
I don't think so.
Oh, all right.
Nice.
I think when we disconnected it, it like
Oh,
stopped.
right. Okay. So for the person on Zoom, Joe V, hopefully I said that right. Can you type in the chat if you can see the icebreaker thing, or just let us know? Yes. Okay, cool. You don't have anybody on Zoom with you, but if you want, you could type in the chat your favorite songs, and I'd love to add it to the pool of songs we're gonna get here. You don't have to if you don't want to. Cool. All right. We'll spend about five minutes or so, and make sure to share it with the people at your table and get to know their music interests, because that always tells you a lot more about a person than you think. I know, yeah, we should get some music playing in here. That ain't a problem.
That's pretty chill. Well, I guess not really chill. It's good stuff. What I really
Okay, Happier by Olivia. Thank you for sharing, Jovi. I appreciate it. Awesome. Oh, awesome. Thank you.
What's your favorite? Oh my god, I don't know. Yeah, actually, I also adopted my mom's like.
Okay. Oh, let's bring it back in. Oh, we'll stop playing Dora. Yeah, take me super seriously with Dora. Anyway, yeah, let's bring it back in. So hopefully everybody has a piece of paper with like 1 to 2 songs that they like, right? Yeah. Okay. Pass them up to the front. And the reason for that is because grab your backpack. Okay, because we're gonna make a Python Decal playlist. So that's our logo, and there's Spotify. It'll be on Spotify. If you don't have Spotify, download the free version. And you will be able to listen to all the music that everybody has played here, and it won't be attached to anybody's name, so it's kind of anonymous. I'll just type them in, add them to the playlist, no judgment. Last semester, we had like, I think 30 or 40 songs, so hopefully this semester will be pretty big as well, and you'll be able to listen to all sorts of bops. And depending on our moods, we may or may not be playing it at the start of lecture. We'll try to, but you know, sometimes you just get like a song stuck in your head and you got to play it. So not always, but we will try to play it as much as possible at the start of every lecture. And before I move on, has anybody not signed this attendance form? Okay, this whole side of the class. All right. So sign this, and pass it around. And okay, I'll give it back to Isla and
Cool. Okay, so back to the kind of less fun things, but all a matter of perspective, you know? So a quick review of what we did last time. Let me move my screen. Okay. So we went over different kinds of data types. So integers, floats, strings, lists, dictionaries, tuples, booleans. We also went over functions, how to make a function, how to call a function, and also variable scope. So where, you know, defining a variable, where that applies in your code. And these are all really important things that, you know, we're just going to build off of today. But something that everything that we've covered so far doesn't do is it doesn't allow our code to make any judgments, right? You can be like x equals 5, you know, y equals 7, but it doesn't like make any decisions per se. So that's what we're going to be going over today. Yeah, you can't change the flow of the code based on what a user inputs. So today we're going to be learning about if statements, for loops, and while loops. So we're going to start off with if statements. But before we jump into that, you kind of need to know a little bit about Boolean operations. So this is kind of a list of some important symbols in Python. We've touched on some of them before, The thing highlighted in red, I just wanted to point this out, the ampersands and the caret, they're not what you think they are. It's not the exponent sign and it's not and. It's something different that I don't really know. So don't use them. You won't need them in this class. The things in this big green box down here, these are different comparison and Boolean operators. So let me see. No, I won't use that. So there's like greater than, less than, greater than, or equal to, less than or equal to. This double equal signs is like equal to. So instead of like defining a variable, it's just a single equal signs, whereas two equal signs is like checking whether two things are the same. And then this exclamation point equal sign is not equals to. So those are just some like kind of like syntax things that you'll kind of just pick up. Two other really important ones are and or. Yeah. And or, these are the two ones that I really want to emphasize. So you can't really see it because of this. Oh, okay. I'm just gonna hide this. Cool. So for and or, so basically how these work is you have two statements and you kind of want to check them. So this is kind of the format. One statement and then another statement. So the rules for and is it will return true if both of the two statements are true, and it's going to return false if one of them is false. And then the other one is or. So this one, the or operator, will return true if one of the two statements is true, and will return false if both of the statements are false. So it's a little bit confusing to think about. I always get confused. When I first learned about this, I was like, how do I remember all these different rules? But it kind of makes sense in practice. So let's do a couple examples. So here's some like quick true and false questions. I guess we can start off with the first one, true and true. Does anyone want to have a guess at what this is? Yeah. True. Well, yeah, it's true. Because for true and true. And then for two, true or false. True or false. Yes, you. True. True. Yeah, exactly. That's true, right? One of the statements has to be true. So even though one of the statements is false, it doesn't matter. It just has the one true value. How about this next one? Number 3. 1 is greater than or equal to 2. Yes. False. Yeah, exactly. We know that that's not true. This one, I don't think we've maybe gone over this, but maybe not. I can't remember. But this percent sign is modulo. So it's basically giving you the remainder of dividing these two numbers. So this is asking the remainder of 5 when you divide it by 2. Is it equal to 1? Anyone have? Yes. True? Yes, right? When you divide 5 by 2, you get a remainder of 1. So that is true. How about 5? So this reads as 2 is not equal to 2 or 1 is equal to 1. Any guesses? I got a thumbs up. Yeah, true. Yeah, so that's true. And just a quick note about this one is the parentheses doesn't really matter. I kind of just threw this in just so you can see how different things can be formatted, but it doesn't really matter. It would return the same thing even if there wasn't parentheses. Which I gave away the answer to the next one. It's also true. Okay, now 7. 3 divided by 0 or true. What do we think this one returns? I got a thumbs up. Any other guesses?
Oh.
Yes. True. Awesome. So this one's like kind of tricky. It's kind of a trick. So this one actually returns error. So how Python reads these phrases is it first reads 3 divided by 0, and when it reads that, it like errors. It can't go any farther. It just says, I don't like that. I'm not gonna read anymore. So it returns an error. It doesn't return true or false. How about this one? True or 3 divided by 0? Any guesses? Another thumbs up. Any other guesses? All right. Yeah, so this is true. So even though one of these statements gives an error, for an or like statement, only one of them has to be true. So it'll read the true value or the true statement, like an 8, and it won't read any farther. It doesn't need to. It already knows that it's going to return true. So almost done. 9 false and 3 divided by 0. What do we think? Yeah.
Another error.
So this one, also kind of tricky. This one's actually false. So kind of similar thinking from before. So false and 3 divided by 0. The and statement, if it has a false value in it, you know that it has to return false because both of them have to be true for it to return true. So again, a little bit tricky to think about. Yeah.
So in both cases, and or we'll read the first statement and then check,
Mm-hmm.
and then read the second statement and then check.
Yeah. So this is kind of 61 AE way of thinking of things. Like in real practice, you're not necessarily going to get into like all these nitpicky things. But it's something to think about when you're like constructing these different statements of like which one you're putting first versus second, because in some cases it does matter. And then this last one, not 2 equals 1. Thumbs up. Yeah, so this is true. So I didn't actually talk about not, but not basically reverses what it was. So 2 is not equal to 1, but then there's a not in front of it, so it will return true. So hopefully seeing some of those examples were helpful. But yeah, you'll get more practice with it. So this is how you construct an if statement. And we're going to be using all these different Boolean operations and statements in writing these different statements. So let's say we want to write a piece of code that outputs, a certain phrase if the variable is greater than 10. So how we would go about doing this, or this is kind of the flow chart of thinking about it. We have an input variable. We want to compare it to the value 10. And if it's greater than 10, let's say we want to output x is greater than 10. And if it's not greater than 10, we want to output x is not greater than 10. So pretty basic line of thinking, just comparing the value to 10 and then, printing out how that value compares. So this is kind of what it would look like in code. This first statement here is basically just a way of prompting the user for an input. It's not super important. But here, this is kind of how an if statement looks like. So it has if, and then these different operations that we were talking about. So in this case, we're checking, is x greater than 10? And then if that's true, it'll go to like the little indented section underneath that statement. So if x is greater than 10, we're going to print x is greater than 10. But then if it's not true, it's going to go to that else statement and it's going to do what's inside the else statement. So it only goes inside like that little block of code if it applies to whatever your variable is. Yes, did you have a question?
Yeah, can you explain a little bit about the colon after the else?
Yeah, so that's kind of just formatting on an if statement, but that's a good point that I should have mentioned. Is for if statements, it's if and then a statement and then colon. So like kind of similar to how like you would write a function where a function is like def and then a name, its arguments and then a colon, and then you indent inside. This is like kind of a similar format to that. So you need to have a colon after your first if statement and then also after your else statement. This else statement is actually kind of optional. You don't need to have an else statement to go with an if statement. You're just typically shown this way, right? Because you're like kind of checking 2 things. If this, then do that. Any other questions? Yeah.
What happens if you input something that is not an integer?
I mean, this code kind of, it has this little int thing, so it like converts it to an integer. Like if you, it's not, it wouldn't actually run. Like if you're asking like the if statement, if it would run well if you compared it. I think if you tried to compare it, it would just error. Like if you said like a string, is it greater than 10? It would be like, what are you talking about? Yeah, this code doesn't have any way to kind of like control for that, right? This is just a pretty basic example, but yeah, good point. Any other questions? Cool. Yeah, so let's say we want to also check the equal case, right? We checked if it's greater than, and we check that it's less than. We also want to check that like middle ground if x is equal to 10. So this is the same flow chart as before, except it has another branch. X is equal to 10. So how would we go about writing this? There's another kind of statement you can throw in your if statements called the else if statement, which is written ELIF, like elif. And this is basically just like another if statement you can throw in. So something to note about if statements is they're like chronological, kind of like up to down. So it's first going to check this statement. If that statement's true, it's going to stop reading. It's not going to read the rest of these statements. But if this first if statement is not true, it's going to go to the next one, check that one. And then if both of these statements aren't true, then it's just going to end at the else and do what's in else. Does anyone have any questions about that? Cool. So now I kind of want to show you an example, like in real time, what this would kind of look like. So let's say we want to find if x can be divided by 2 and by 3. So I sent out an announcement about like a Jupyter notebook to download. So if you've downloaded it, that's great. If you want to pull it up, that would be awesome. But if you didn't have time to download it, or don't have the capability right now, that's totally fine. You can just watch us code. Let's see where I put it. Okay. And just as a quick kind of reminder, I can show you how to open up Jupyter Notebook. So make sure the notebook is on somewhere on your laptop. You can find it pretty easily. Like mine's on my desktop, so I just go to my desktop. But to open Jupyter Notebook, right, you're just going to type Jupyter Notebook. And this will give you access to opening up that notebook. So yeah, and then you can just click on it. So I already have mine open. It has the first example we've already gone over in here. But now let's say we want to write a nested if statement. So you can put like if statements inside of each other. Like you can be really creative with it. You can do whatever you want. So let's like try an example like that. So we want to find if x can be divided by 2 and 3. So does anyone have any ideas of what we could try to do first if we wanted to start writing these if statements to check these conditions? If not, I can get us started. So we want to check if it's divisible by 2 and 3. So here I'll do x and then this modulo symbol, right? This is checking if there's any divisor or any remainder when you divide the two numbers. So let's do x, which is our input number, modulo 2. So we're checking if we divide our input number by 2, and now we want to check the remainder. So how we can do that? Yes. Oh yeah, sorry. Is that better? Okay, great. Sorry about that. So x modulo 2. To check the remainder, we can do these two equal signs, and we'll see if the remainder is 0, right? If it's divisible, then there will be no remainder. Awesome. Does anyone have any ideas about the second if statement? So it's checking this first condition and then it's going to the second one. Yes.
Same thing except modulo 3.
Exactly, yeah. So x modulo 3 equal 0. So we're checking these two conditions. And kind of the way to think about this is it's first checking this first one. And if it like passes that test, then it goes inside to this next test and checks that one. And then if it passes both tests, it'll go here to this one. So here we could just like print divisible by 2 and 3. Yay. And our else statement, this can be whatever you want. Print not divisible by 2 and 3. So that's kind of an example of what a nested if statement looks like, and kind of the way to think about things when you're writing an if statement. Cool. So let me go back to the presentation if I can find it. Okay. Yeah, so this is, what we just wrote. It's checking the both conditions and then doing the different print statements. So now I want you all to try and do your own writing of if statements. So there's another one lower in that document. I think, yeah, I'll pull it up in a sec. But here's like all the different conditions we want to check. So we want to check if the input number can be divided by 2, but not 3. Can be divided by 3, but not by 2. And it can't be divided by either number. So feel free to work with the people around you. Those are the answers. Don't look at that. So yeah, here's kind of, I'll zoom out a little just so it's all in there. So if you don't have a laptop or you don't have the demos open, this is kind of what it looks like. You can kind of just think through, what would you write? Or if you do have a laptop, feel free to fill that in. Yeah, but feel free to work with the people around you. Shouldn't be silent.
Just double up. Go to the first one. I'm just gonna do things a little different. First print. Yeah.
So I just have this now.
So the first thing that we actually want to do is have they kind of have a thing. So those 4 cases are all in because
Okay, so what would you pick after the
not after, before that print, you actually want the second if statement. That's double this. 3. We're going to check both of those. And then the nested if statement. No, just and then just
Any questions so far?
I took CS 10, so I'm like a little ahead of her.
Yeah, it's like same idea. Did you guys actually get coding on those yet, or you're going to-
No, but see, the entire second half of the class was
Okay, cool.
yeah. So I've got the basics.
So we nested it, and it nested it. Because we were expecting like 2 and 0. 3. Oh no, there's.
Yeah, and then hit tab before that. Because the if statement has
Can be divided by 2.
yeah, that'll be on the same tab space as the second or as the first nested.
Yeah.
Oh no, it's not LA. There's a better way to do this. We can just say else.
Okay.
This else is in tandem with the first nested if. So we're still within the first if. It's like
Okay.
first if, we have a second
All right, friends. It doesn't matter if you haven't finished yet. I just want to move on to make sure we cover everything that we need to. But it's totally okay if you didn't get to finish this. I'll be posting the solutions and everything. But it's also on this slide, which is cool. So this is one way to solve the problem. You know, there's different ways to go about doing it. But feel free to test it out yourself, right? You can like run that cell, input values, and see if it returns the right thing. So yeah, and again, I'll be posting the solution, so no worries to copy this down or anything like that. And now I'm gonna pass it off.
So we just learned how to control our input and output, and now we're going to move on to how to keep doing the same thing like until we get to our desired outcome. So like running code an amount of times or running it until something happens. And if statements don't do that, unfortunately. So here's like, so there are 2 types of loops. One of the types of loops are called for loops. And the way how I kind of think of it is you use for loops like when you go to a fast food restaurant and you're paying, you pay like at the things, you can't get your food until you pay. So for loops are like that. You can't get another iteration until you tell in your statement how many iterations you want. And if it's true, then it'll like once it is no longer that iteration, it'll exit the loop. And if you keep paying, you'll keep going through the loop. And this is like the syntax for statements. It's pretty similar to the syntax for if statements, but now you have like your statement, like the thing that you want, and in the amount of times you want it. So like, let's say you want French fries and you want it like 7 times, and then you'll get 7 French fries, but you have to make sure you explain here how many you want. Yeah, and this is just like more words explaining what I said. In the example, it would be if you want to print like numbers 0 to 100, the syntax would look like, okay, so like the syntax, if you want to print from 1 to 100, so like it would be including the first number and it would not be including the last number. So if you wanted to do 0 to 100, it would be 0 to 101. If you wanted to do 1 to 100, it would be 1, which is the number you're starting with, but it would be plus 1 that because the last number is not included. And when you run this, it'll print out 1 to 100. The next kind of loops are called while loops, and kind of relating back to like food industry. If you go to a restaurant and you sit down, you can order as much as you want, but you're not going to be paying until the very end. So you can keep doing things, and you're not going to do. That's kind of like how while loops work. you just keep doing the thing until, and then whatever, whenever the statement is like, once you're, like, you can keep doing the thing and, sorry, once you keep doing the thing, and then once you're done eating, you can pay and then you can leave. So this is like the syntax. This is also like the kind of thought bubble you can think of. And syntax again, it's very similar to the if and for loop syntax. And here is examples. So over here, you have I equals to 1. And as long as I is less than 6, it'll keep printing. And notice at the end, we have like an iteration. So it like moves it up 1. So if you didn't have that statement, I would always be less than 1. I mean, I would always be less than 6. And you'd get what we call an infinity loop. And then that would make, it would just, the code would just never stop running. And the same thing would happen here, except, okay, yeah, let's do this example. So for while I is less than 6, what do you guys think the first output would be? Like, so it's 1 is less than 6, and then it prints I, so it'll be 1. What do you think the last, like once I is no longer less than 6, what would the last input be? Output be? Yes? Yeah. And then then once it's 5, it'll be +1, and then it'll no longer be true. However, this one, the first output would be, does anyone know what the first one would be? Yes, 2. And what would the last one be? Yes. And yeah, this is I kind of rushed the gun with that one, but that would be what you would, actually, yeah, based on what I said before, what do you think will happen if we run this?
The computer gets rather upset.
Yes, it'll just keep that terminal open and you'll just be like, what's happening? And to just get rid of that, you just press the escape button and everything would be fine. But it probably, if your code is just running and running, it probably means you have an infinite loop. Oh, and here's a fun meme. You can think about it. Yes, make sure to exit your loops always, or else infinity loops. That's like a really big problem. And here's another funny meme. You can read it. Because you're always outside when you're getting milk, so it's an infinity loop. It's so funny. It genuinely is. Demo time.
Yeah, so that's kind of a quick overview of like if statements, for loops, while loops. But let's get some practice with for loops. Because I think they're really cool. And I always get excited when I write one that like actually does the thing that I want. So yeah, it's pretty exciting. So I'll just go through this example with all of you. So I guess we can run this first cell. You all can do this too. Right, so we're printing for I in range 1 to 21. Right, like Mohammed was saying, like the last element in range is exclusive, so it only goes to 20. Something to note is this I variable can be anything you want, kind of. It can't be like a number, but anything, any like letter or word. So let's say for hi in print hi. It's the exact same thing. As long as you're consistent, you can make it whatever you want. So for number, print number, the exact same thing. I think that's really cool because you can kind of customize it, and however it's best for you to think about your different variables and stuff, you can put whatever you want in there. So here's kind of a more like data, not data oriented example. So this is a list of some astronomical objects. Right, this is a list of strings. We've gone over this before. Let's say we wanted to use a for loop to print through all of the objects in this list. So how we would go about doing that, we want to iterate over every element in this list. So our list is called objects. And I will call this, let's say OBJ, like as a short for object. For OBJ in objects, our list, print OBJ. Oh, I need to run the above cell. Yay. And again, we can be like, I don't know, Astro, print Astro. It's the same thing. But then if I like left this as like OBJ, it would, so the reason this looks weird is because it's remembering what I inputted before. So it's just repeating the last element again and again and again. But as long as you're consistent within your for loops, it works out okay. So this one's a little bit more challenging. This one, we're gonna do a nested for loop. So right, like we can like put if statements inside if statements, we can put for loops instead of for loops. Not the most efficient thing in the world, but it gets the job done. And we can also put if statements inside of for loops, right? You can like do whatever you want. It's pretty cool. So let's say we want to print all of the objects in this list that are supernova. So if it's a supernova, it's going to start with SN, right? SN for supernova. So let's write a piece of code that will only print out the supernova objects in our list. So let's start out the exact same way as before for OBJ in objects, right? So for, you know, each element in our list, objects is our list. So for each element, what do we want to check? We want to check the first two letters. So what we can do is you can iterate through elements of a string just like a list. So like, oh, no, I'll just go for it. So you can iterate through elements of a string or characters in a string just like a list. So for, let's do letter in OBJ. So this is kind of confusing to think about because it's like two inside of each other. But I'll show you this. So let's say we do objects, or here, I'll just do this. It's like this. So if you have a string, let's say dog, and I wanted the first letter, I could do dog 0 and it would give me D. Or if I did 1, it would give me O, which is pretty cool that they like work like lists. So we're doing the same thing here. So we're looping through all of the different characters in our object name. So 2 for loops working together. So now we want to check if letter, so if the letter, the character that we're looking at is equal to S, or letter is equal to N, right? Because we want to check if either of the characters in our list is equal to S or N. Question? Yeah, this would be case sensitive. Yeah. So if all of these conditions are met, let's just print out whatever our object is or whatever our name is. Yes, question?
Wouldn't that also print the ones that start with N?
Yeah, so that's a good point. If we're looping through all of the elements, all of the strings in this, it would also pull out like this one here. Yeah, so let's only do S because I've conveniently chosen these so that there's only capital S's in the supernova one. And I'll show you a little bit kind of cleaner way of doing it right after this. But yeah, let's say, let's get rid of the N and just do the S. And we want to print out the name. So the name in this case would be OBJ. That's our object name. So let's see, I ran the list, cool. So now if I run this, it gives me the 3 different supernova in our objects list. Cool. I know that was kind of a lot. Does anyone have any questions about that or want me to go over anything again? Cool. So another way to write this that's quicker and a little bit cleaner and doesn't use nested for loops, but I wanted to show you that nested for loops work. We could do for obj and objects, start the exact same. But instead of looping through all the different elements in the list, we could just check if obj, the first element, right, the first letter in our object name is equal to s, and obj1, so the second character is equal to n. And then we'll do the same thing, just print. So this is kind of a more precise way of doing it, right? So even if we had objects with an S in it, a capital S in it, this would still work out fine. And it returns the exact same thing in this case. Cool. Yes. Yeah, so there's this button right here, this little like plus sign. If you click that, it'll make a new cell. There's also a shortcut, but I don't know off the top of my head. But yeah, I just clicked the little plus. Yeah, and then to run a cell quickly, at least on my computer, it might be different for some, it's shift enter or shift return. And that'll run it without you having to like click the run button because that's annoying. Cool. I guess we don't have really enough time to do another example, but maybe I can start it. Unless anyone has any questions or wants me to put up the code longer. Cool. Yes. Yeah, so we're gonna post the slides at the end of the week. But I'll be posting the solutions like right after lecture. And so, yeah, it'll have these and these other examples. Cool. So I guess I'll just start this. So let's say we wanted to make like a dice simulator. So we wanted to like have it roll like a random number and we want to like guess, you know, and it's a 1 out of 6 chance that we'll get it right. But so what this would do is prompt the user for a guess, and then we check it with the dice value and see if we guessed the correct thing. So this is kind of an example using a while loop. So how we're starting out the while loop is we want to keep guessing until we get it right. So our while loop starts off with while our guess is not equal to the correct dice value. So that's how we're kind of initializing this. And then we're prompting the user for a number. So have the user input a guess so they can type in whatever value they want. And we're out of time, but I will post the solutions. That's the introduction to this problem that you will see the answers for after this. Cool. Thanks for coming to the first in-person lecture.
Don't get up just yet.
Oh, sorry.
No, it's all good. But I want to catch you before you leave. We can also kind of pick this up on Wednesday.
Oh,
with
true.
any remaining time. So we'll get back to that like demo, and you'll be able to make a dice roller next
Woo.
lecture. Super cool. Thank you everybody for coming. There was a lot of you here.